And I think everybody had enough time to click the button, and otherwise we can see them later joining in. Good morning, good afternoon, good evening, depending on your time zone. Good day. Let's keep it there. Welcome to our first webinar. Hopefully, it's entertaining to you guys and girls, of course. So to kick it off, we'll just quickly introduce ourselves. And before I do that, if you have any questions throughout the webinar, we'll handle them at the end. You can use the Q&A section in the webinar at the top, most likely to ask your questions, and we'll address them at the end. So to start, my name is Olaf Hartong. I'm one of the founders of FalconForce. And on the day-to-day, I primarily focus on the detection engineering and security research that we do. I studied documentary photography, did that for quite a long time until I discovered security, and now here we are. And of course, I'm not alone. I'm here with Henry.
Yeah, good morning, afternoon, or evening. My name is Henry Ambartsumian. I gave myself the title Offensive Defender. I have a background in offensive security. I spend a lot of time doing a lot of different offensive types of work, mostly red teaming. And nowadays I'm trying to use my offensive background to defend organizations, primarily by building detections and other things related to detection engineering. Hey, go ahead, Olaf.
Oh, sorry. Yeah, just a little bit of background behind FalconForce for the people that don't know us that long yet. We also don't exist that long. We're celebrating our 5th birthday this month. And we're all a group of highly skilled individuals where we've been working together for several years prior to starting FalconForce. And our primary goal was to deliver cybersecurity services with a more purple approach, where always red and blue are combined and the knowledge is shared to all of the people that we collaborate with, so that we can give them as much clarity and context from both perspectives, how an attacker would approach it and how we can best defend against that attacker. And in order to do that, we do a lot of research on both ends, to properly understand how all the security measures are working and how we can bypass them and improve them again. And we work with a lot of technical people in corporates, where we try to achieve the highest security maturity that we can achieve for them.
Okay, so let's dive a bit more into the content on what we're going to do today. So I think we have a couple of goals for the session today. I think the first one is, of course, the topic is about building custom detections and bespoke detections. So the first question you can ask yourself is, do we even need custom detections, or why do we need custom detections? So that will be the first topic of today. Then we'll dive a bit into trying to understand what makes detection engineering so hard. What do we need to what challenges do we have when we do detection engineering? And after that, we'll look into how we approach detection engineering. So we'll just give some insights on the process and the technology that we use for building detections. And finally, we'll talk a bit about the managed detection engineering service which we offer. Which will come towards the end. Like Olaf said, we'll handle the questions towards the end. So if you have any questions, please put them in the Q&A. Since we'll do them at the end, also provide some context for your questions, so we know what you meant with that question. If possible, for example, refer to a specific slide or so if that's applicable for your question. So the first question is, why do we even need custom detection content? A lot of people ask themselves, do we even need detection content? There's a lot of things available out of the box. If you get an EDR product, it has a lot of out-of-the-box detection content. Plus, on top of your EDR, you have a lot of other security products. For the Microsoft stack, you have things like Azure Identity Protection. You have Defender for Cloud, Defender for Identity, and a whole bunch of other defenders. guess the new name is Defender XDR for most of those. And the question is, do we even need custom things, or isn't the stuff which we buy from Microsoft, isn't that enough? I think to be fair, the answer is it depends. If you're a low-skilled, if you're defending against a low-skilled attacker, if your threat model says that your threat actors are most likely low-skilled, then probably the built-in detection content is already enough for you. If you're only afraid of ransomware, that's your threat model. The biggest risk in your threat model is ransomware. Then you're likely have sufficient coverage with the built-in detections. However, it gets a bit different whenever the threat model is different. If you're trying to defend against highly skilled attackers or more skilled attackers than the ransomware groups, then the out-of-the-box detections might not be enough. And the way it works is that the out-of-the-box detections, and they have to work for everyone. So let's say if we talk specifically about EDR, for example, the detections which are built in your EDR, they are the same across the world. So everyone using the same EDR has the same detections. And those detections need to work for everyone worldwide. So every machine in every organization which deploys a specific EDR, so let's say it's Defender for Endpoint, those detections have to work in a sense that they have to be accurate enough to detect an attack, but also it has to work in terms of the number of false positives it generates. And you can already imagine that it's quite hard to build a detection, to build one specific detection which covers and works for everyone in the whole world. And that's one of the challenges which you have if you're building out-of-the-box detection or using out-of-the-box detections. I mean, if someone already here tried before trying to build custom detections, you'll see how many misbehaving enterprise software there exists, which really behaves like it's malware sometimes. And those are the issues which you're facing when you're trying to defend against highly skilled attackers. Another issue is that attackers also test their attacks against the detections which are built in. So if I'm doing a red team, if I'm an attacker, I'm gonna try my tradecraft against the EDRs to understand if the EDRs detect my tradecraft, yes or no. And that's something which high skilled attackers often do, while the low skilled attacks usually, or the low skilled threat actors usually don't. So that's one of the other, let's say, differences between your threat model. So what am I defending against? And basically the idea is that if you use custom detections, you can build your own detections which are specific to your own environment, and you can tune those detections to make them work in your own environment. So if you have a nice detection covering a specific attack technique, but there's this one weird application misbehaving, or there's this weird department using a specific software product which is triggering your detection, it's pretty straightforward to remove those exceptions from your detection logic if you're building custom detections. While that's not possible when you're using out-of-the-box detections, there the tuning is significantly harder. So basically what you can achieve with custom detections, assuming that you're trying to defend against highly skilled attackers, is you can have less false negatives due to blind spots, because you can build detections that are specific to your organizations and don't have to work for the whole world. And you can have less false positives, because you can do more fine-grained tuning of your detections. So one of the questions is why are there even blind spots in existing products? So how does it happen? Surely Microsoft or some other big name vendor should have proper detection coverage, right? And there are a number of reasons why these blind spots exist in security products. I think the first one is a lack of correlation. Of course, your organization is a pretty big and complex interlinking organization, and if you have different security products, they do their job, but they don't talk to each other. So Defender for Endpoint doesn't correlate, let's say, their logs with the security event log, for example. Or Azure Identity Protection doesn't correlate XDR logs to see if there are if there are things related happening in the cloud in your Azure identity, which impact your endpoint behavior. And because of this lack of correlation between different products, the security products have a blind spot, and you can fix that blind spot by building your own detections and correlating the different data sources and data points which you have available in your environment. This gets even worse when you have, for example, products like Okta, let's say, and not that Okta is such a bad product by itself, but the fact that, let's say, you're using a non-Microsoft product with non-Microsoft formatted logs, and using Microsoft security tooling to protect against that. So Defender for Cloud, for example, or Defender for Cloud Apps combined with Okta will not give you the results which you can achieve based on your custom detections. So that's the first reason. Next one, I think we touched upon that in the previous slide, but the detections which the vendors are trying to build, they have to work for everyone. So the detection logic, which is built by the security vendors, they have to work for everyone, and they have to work in a reliable way for everyone. We can't have detections shipping in Defender for Endpoint, shipping in some other security product, which causes a significant number of false positives, because that would flood your SOC, and that's not. If that happens too often, people will just walk away from that security product. So that's a second big reason why there is quite a blind spot in a lot of security products. The third point is that external products don't have visibility in your environment. They lack the understanding which is necessary to build effective detections. I guess one example is if you're building detections against ADFS, Active Directory Federation Services, and let's say you want to detect the Golden SAML attack, which is one specific attack done against ADFS servers, then this attack will only, or this detection will only be reliable and will only be successful if you scope that detection specifically on ADFS servers. Because the same logic applied, same detection logic applied to a non-ADFS server doesn't make sense whatsoever. But Microsoft doesn't really know, at least not from a cloud perspective, which server is your ADFS server. So they can't really tailor specific detections to specific groups of servers or specific groups of users to make more effective detections. So that's another limitation which you have with out of the box content. Next, we have limited research. So most of the security products we see out there, they do some research, but the detections are mostly built on public tradecraft. So stuff which is basically published online, where some security researchers or other security companies, they oftentimes it's offensive security people publishing different attack techniques. The security vendors then build detections specifically for that attack technique, but without too much variation of that attack technique. Plus, they rarely build detections for unpublished tradecraft, while we know that most of the skilled attackers have a lot of tradecraft available, which they don't publish online, for a lot of good and bad reasons, I guess. So that's another reason why the stuff out there is not sufficient. And from your perspective, that's not so much the tradecraft itself, but it's more focused on the fact that given a specific attack technique, you also want to build detections for specific variations of that attack technique. And what we see is that most security products don't build detections for those variations. They're very narrowly scoped to exactly what's published online. The fifth point is limited tuning possibility. What we mostly see, we mostly work with the Microsoft stack. What we see in the Microsoft stack, it's really hard to tune out-of-the-box detections in the Microsoft stack easily. So there are nowadays some flaky on UI tools in the Defender for Endpoint or in the security portal for Microsoft to tune out-of-the-box detections. But they're just based on simple rules, like if a specific column has a specific value, then filter it. But more complex filtering and tuning is lacking in the built-in detections of on the Microsoft side, at least. I can talk about the other things, the other products. And the last point I think is cloud complexity. So one thing which makes detecting attacks in the cloud even harder is that the behavior of malicious actions and legitimate actions in the cloud are very, very close to each other. And it's often the combination of the initiator of the action itself, and the target, so the combination of those three, which determines whether or not an action is malicious. And in order to make that decision, you really need to understand your environment and know your environment. And that's really hard if you're just coming from outside without any knowledge on how, let's say, your organization is using your cloud environment. So why is detection engineering hard? I think, like Olaf mentioned before, so we're partly a consulting company. So we see, let's say, a lot of different organizations from the inside. We talk to a lot of SOC people. We talk to a lot of internal detection engineering teams. And basically, this is the combination of things which we digested from all the conversations we had before with different detection teams. It's often a combination of three things that you need to have successful detection engineering. So you need to have people with hands-on offensive security skills. You need to have a realistic lab environment to build your detections, and you need time and focus to do that. And the one thing I want to zoom into a bit is the fact that I think the biggest issue we see in existing detection teams is that detection engineers are sometimes building detections without first performing the attack in a lab environment, obviously. So detection engineers building detections based on assumptions. So if an attacker performs this step, then I assume I will see this specific event in my data. I assume I will see this telemetry in my logs. And that assumption doesn't always hold. And sometimes that assumption is not even from the detection engineer himself or herself, but it's from someone else. So basically, a blog post said that if you perform this attack, you will see this specific event ID, you will see this specific event type. And that's a big gap, I think, in how detection engineering is handled. We firmly believe that if you want to build solid and high quality detections, that you really need to perform the attack yourself first in the lab and see what's going on, and also understand what the attack before trying to build a detection. So zooming in on three different aspects. I think that the first one about offensive skills. If you want to build solid detections, you really need to perform the attack hands-on, but also perform variations of the attack or modify the attack script a bit in order to execute the attack, to generate the logs and the telemetry before you can write the detection. So basically, if you're a detection engineer, you need to be very comfortable with all the offensive security tradecraft. So let's say you're building something for Kerberos and you want to build a detection for, I don't know, let's say AS rep roasting, for example. You need to be able to do AS rep roasting in your lab environment, hands-on at that moment, to generate the logs, to be able to build solid detections. And the same holds for doing stuff with, I don't know, like PPL services, protected processes, or you want to do stuff with ADCS. You need to be able to do all those things on demand. So that's the first thing on hands-on offensive skills. But on top of that, your detection engineer also needs to have the blue team skills required to create production-ready detections. And what I mean by that is that when you're building detections, there's more than just identifying the right event or the right combination of events to detect an attack, you also need to deal with things like ingestion delay of different tables, potential different data sources. You need to think about tuning of the detection. You need to think about documentation on follow-up responses. So those are all kinds of, let's say, skills which the traditional, I guess, between quotes, SOC people and the traditional detection engineering people have, but not every offensive person in your organization, not every red teamer in your organization has those skills. So you really need to bring those two skills together in order to build really effective detections. And of course, you can split those roles in two different people, or probably perhaps even more than two different people. But you lose some of the efficiency, of course, and some of the finesse if it's done by one person. But even then, I think it's still better to do it with two than building detections without performing the attack in your lab environment. One tip which we want to share is that if you split the role between two different people, make sure that those two people sit together in the same room and make the detection and do the attack together. Because what doesn't work is if you have a red teamer sitting in a different office, you ask him, hey, please do this attack for me. He does it. And then you start digging up into the data. That doesn't work nicely. You're missing a lot of the nuances of a specific attack. So from that perspective, you really need to sit those people together, brainstorm together, and build the detection together. And then the next point is to have a realistic lab. So of course, you need to have some place to build those or to execute those attacks against. And the lab needs to have some specific. It needs to have a setup which is realistic for your environment. In order for you to simulate those TTPs, generate the logs, and build proper detections. I think if we look at what's common out there in terms of requirements, I think you mostly need an AD domain. I would say still like 80-90% of the big organizations rely on Active Directory for on-prem stuff. So if that's what your organization has, you need to have some kind of representative AD domain. You need to have some workstations enrolled in there. You need to have some servers in your AD domain. You need to have some specific services depending on the detections you're building. So the most common ones are things like ADCS, like Active Directory Certificate Services, ADFS, SCCM, SCOM, potentially Entra Connect if you have a hybrid environment. And then you need to add some tooling to it. So for example, you need to have your EDR product. I mean, in our case, we're mostly using Microsoft stuff. So you need to have Defender XDR licenses. You need to have Defender for Identity, Defender for Cloud, and all those other things installed and rolled out. And you need to have your Sentinel and your SIEM set up. And potentially things like Intune, if you want to build Intune detections. Entra ID might be relevant. So if you want to do stuff with Entra ID and with conditional access policies, for example, you need to have those things set up in your separate environment, and make sure that this environment is really separate from your production. You don't want to do this type of stuff in your production environment. And I think the final thing which I wanted to share on this topic is that you really need to clean up your lab because you're constantly performing attacks on your lab environment. And these things break at some point. If you just keep hammering the lab every day, trying to replicate attacks, trying to build detections, you really want to clean up the lab every now and then and start from scratch again. I think the final point I want to mention is time and focus. So I think doing proper detection engineering really requires 1 to 2 full-time engineers to work on that. What we see happening from time to time is that people are doing detection engineering in the off time. So let's say when there's no incident going on or there's no active incident going on, that you get some time to do detection engineering. But this really doesn't work properly and doesn't scale properly in most environments we've seen. So really try to allocate sufficient time for detection engineering and building detections in your environment. I would say on average it takes 1 to 3, let's say, full days including engineering and testing and documentation and everything around that to build a production-ready detection. So starting from, let's say, nothing to having a production-ready detection, including all the testing and all the documentation, is 1 to 3 days, depending on the complexity of your detection.
Yeah, and how we do this is sort of already discussed in the previous slides, right? But to clarify it a little bit, we've built one big lab environment, which is totally not our production environment, and it really isn't. We call it the ball pit just because it's very easy to distinguish, and this is used by both our offensive and our detection engineering colleagues, which has the added benefit where the red team tests all of their new attacks that they want to be doing in a customer environment, so that they can validate that there is no out-of-the-box detection for it, as Henry just discussed, and assume that an attacker will always do this, right? So they probably figure out a way how they can find out what kind of security tooling you're using. They can install that, buy it maybe, and test all of their attacks against it. Benefit for us is since we share a lab, we can validate also our custom detections this way. Because if we have already built a detection for certain behavior that the red team emulates, we can see if it's still working if we don't already tested it ourselves. Plus, since we share the lab, we can also work together with the offensive colleagues to figure out how to build detections for new behaviors that they're doing, right? So as Henry discussed, we're sitting often in a room together, looking at the screen, both our screens, and figuring out like, hey, what did you do? How does that work? What kind of logs can we utilize to actually build a detection for these kinds of things? As we mentioned, so we've built a lab that replicates what we commonly see as configurations in production environments. They're not always the best, right? So our lab is equally unhardened as a common enterprise is. The only biggest difference there is that we set most of the logging to a more verbose standard than you would have in production. And of course, this is more costly, but in a lab, that's actually what you want because you can understand what kind of telemetry would be available, so we can advise clients to consider onboarding it if it's not a too expensive data source to onboard. But at least we know that there's a detection possible. And sometimes there, of course, isn't. So then we also know that it's challenging. And in our lab, we of course keep it up to date. So we patch it as you would also do in a production environment. The only difference is we snapshot our machines and we roll back every weekend so that we have a clean slate. And this is primarily done so that we don't taint our machines too much, and there's residual activity from a previous attack, poisoning the logs of the detection that we're actually trying to create. So you're looking at the wrong data. That's why we want to have a clean slate every time we do some bigger research. And if you have your own lab, if you've ever been a sysadmin, you know that stuff breaks for whatever reason. Sometimes it just breaks, and you have to figure that out as well. So even maintaining a lab, you should allocate some proper time for it. I think we spent at least a day a month just troubleshooting, improving, refining, sometimes updating software as well. So from a detection engineering perspective, we have a fairly simple flow where we come up with an idea, we put it on the backlog, we have a light agile process for that. And every week we have a stand-up call where we have a planning session where we discuss ideas, prioritize them, and discuss like who's picking up what. Sometimes an idea on the backlog turns out to be something that either from experience we know it's not possible, or it's not feasible, or there can be multiple reasons to do this, so we abandon it. But in most cases, we take it to the R&D phase where we follow a flow like Henry discussed, which I'll highlight a little bit in detail in the next slide, where we replicate the attack and actually figure out if there's feasible telemetry for detecting the behavior that we're looking for. In some cases, it's just not there, so we abandon it. Sometimes, though, due to our contacts with either Microsoft or another vendor, we know that they're developing telemetry for it and it's in preview or it will be released to production at some point. So then we put it in blocked mode because we already did the research. So why waste it? And at some point, we either still abandon it if the logs that are released turn out to be useless, or we put it back on the backlog so that we can actually refine it and build it into a proper detection. So once we've actually built a detection, let's say I did it, we use a Git workflow. So at some point, I'll do a pull request in Git, and then it goes into a review stage where Henry will look at my detection. He will figure out, does his documentation make sense? Do I understand what he's trying to detect? Does the detection make sense? Can I bypass this as an attacker? Because that's also part of his role as a reviewer, but also as a red teamer. He needs to figure out, can I still circumvent that detection? So sometimes that's possible. Quite often there's feedback on the detections that at least I create, but everybody does. So then it either goes back into the R&D phase where I need to refine it a little bit, or sometimes I just need to update the documentation. And at some point it, of course, gets approved. And then we can deploy it to our own production environment because we like to dog food. And if it turns out to be valuable, we'll also deploy it to our customers. That's not everything. Of course, everything you create, you also need to maintain. So we also have planned maintenance where we refactor our detections quite regularly, and even sometimes rewrite the whole detection because we either learned a new trick and have a better way of detecting it, or we just refine it because logs changed or various other reasons. So from a detection engineering cycle high level, or a little bit more detailed than the high level, we come up with an idea, right? So as I discussed before, that can be either a MITRE ATT&CK technique or a new red team trick that we found, or we also follow Twitter and all these other platforms. So we figure out a new technique that we want to detect. And then the most fun bit is we investigate and research. So we try the tool, we try to build our own version of a tool. We'll look at the source code of the open source tools that do the same behavior, and we replicate as much variance as we can in our lab environment, and we look for the most common denominators in the behavior, or we write several detections based on the behavior if it's very different and it doesn't fit into one detection. So that's basically where we in lab build our detection. So we start with a sort of threat hunt and we refine that into a detection that in the lab looks great. But of course, the lab is not production. So at some point, we'll take it to production and we'll test it at a couple of clients to see how noisy is it. Is there any way where we can improve it? We can contextualize it a little bit more with some reference lists or some other environmental specific information. And once we're happy with that, we can actually deploy it into production. We can report, write the documentation, and plan our maintenance for additional improvements or additional filtering that we need to do. And of course, everything is fully documented. Otherwise, there's no way to transfer knowledge. And I think that's even the most important bit in a detection, right? It's great that we find something, but if the documentation is useless to the analyst, the value of the detection is useless because nobody can actually follow up. Of course, people make mistakes. So that's why we try to automate as much as we can. So all of our detections are in code. As I mentioned earlier, we store everything in Git, and this is our single source of truth. So every time we make a change, we have automation pipelines that do all kinds of validations to see if the schema is still correct for our YAML files, if it follows our best practices, like naming conventions, if we use the right functions, if we have to use the right variables, all these kinds of things. We even use a language server in Gusto that validates the syntax of our whole detection before it even goes to the platform. And on top of that, we also dynamically generate our documentation based on the same YAML file that can output either into Confluence or Markdown. We even have a customer that wants them in Word. Don't recommend that, but it works. And it's the same for our maintenance. So we try to automate as much as we can, but of course it's still human work. So we can validate automatically, we can deploy automatically. Maintenance we can pre-check automatically. Like for instance, if we have URLs in our documentation, if they still provide the data that we want to have. So if there's a 404, then we need to update it, for instance. So all these small checks we can automate. And in the next webinar, we'll probably detail way more how those process flows are working because we're limited on time. And it's the same for testing. So just assume everything at some point will break. So we need to test our detection. So again, we automate most of that for the ones that are feasible to automate. And things break for all kinds of reasons. The world around us changed, so Microsoft might do an update to their schema, or there's some downtime in the cloud, some data doesn't transfer. Maybe one of the servers broke down. That's also what we saw at a client where they had 14 domain controllers, and one of them, for some reason, didn't send their event logs anymore. So if an attacker was lucky to hit that machine while doing his attack, the telemetry would never show up in Sentinel for that customer. But sometimes also people at the vendor make changes that are accidentally giving us blind spots. So one of the ones we recently discovered was that Microsoft made a change to the EDR configuration where XLL loads were not shown up in the device image loads table anymore. So it always worked. We had a great detection for it. And for some reason, at some point, it didn't work anymore. And there's still an issue with the Graph API logs that also don't give you the full telemetry anymore. For some reason, some bits are just never arriving. And there's all kinds of things. So even Azure changes constantly, like any cloud provider. And sometimes also the schema behind the logs can change, where some fields are named differently than they used to be before. And this is probably documented somewhere, but it's not always the easiest way to find it and access it. So at a minimum, if you want to go into this direction, make sure that you create a lab as we just highlighted. And very important to have those clean VMs, because you never know if the telemetry that you generated is only the telemetry that comes from the attack you did, or that there was some prior stuff that was still on the system. And what really helps is to have a really good editor to work with code. So in our case, we use VS Code primarily because it has really good YAML support, where you can have a schema that validates and even allows for a lot of autocomplete functions. Plus, we can also build our own extensions to validate our detections locally before we even commit them to Git, so that we know that the pipeline will mostly succeed before we even test it.
Yeah, so talking a bit about the service which we offer. So like we mentioned before, we have the managed detection engineering service which we offer. I just want to clarify a bit on how we came up with this idea. So basically there are three things which led to this service. So I think the first one is we noticed that there are a lot of teams struggling to build high quality and high fidelity detections to catch the really advanced threat actors. The basic stuff was usually covered either by out of the box stuff or by specific IOCs. But the really advanced stuff was basically being missed all over the place, especially the well-known red teams that they were being basically going through the environment without triggering any detection. That was the first one. The second one is we noticed that a lot of the teams that were actually building detections were making some common mistakes. So things like using IOCs instead of behaviors, so using IP addresses, file names, and other, let's say, easily replaceable indicators to build detections instead of building high quality detections built on actual behavior of the attack. So it's really about what does the attack do, not so much about what does a specific tool do. But also things like building detections without first running the attack, like I mentioned before. So just building detections based on the expected telemetry, which will be produced instead of the real telemetry. And also sometimes we noticed some people were introducing large blind spots in their custom detections due to a lack of understanding of how the attack exactly works in depth. So that was the second one. And the third reason was basically time. So we saw a lot of, I think that this is also one of the biggest one. A lot of teams are struggling with finding time to build proper detections in their environments, especially build the detections, but also maintain those and also keep up with new attacks and build detections for those new attacks. So those are the three main reasons why we offer this service. And what we offer is the following. So basically, we offer high fidelity Microsoft specific detections. So it's all based, sorry, on the Microsoft stack. So it's either for Sentinel or for the Defender XDR portal, which of course is now being unified into the unified security portal. But the detections themselves are broader. So detections are also for Azure and AWS and Linux and Mac OS. But the platform is really focused on the Microsoft platform, on the Microsoft stack for detections. Those detections are really built and tested by purple teamers. So we have people doing both offensive and defensive work, like myself and like Olaf, that really build those detections just to make sure that we have high quality detections and we really understand the attack and the behavior of the attack to build those detections. On top of that, we implement and we maintain the detections for you. So basically, we make sure the detections which we build are staged or potentially deployed in your environment. Those are tuned to your specific environment. And also we maintain those. So we make quite regular updates to detections and to detection logic. And we're responsible in this service offering. We're responsible for updating those detections in your environment to the latest version. And finally, the detections which we provide have a low number of false positives because they're really built on the attack behavior. And the way it works, let's say more process-wise, at least in our offering, is that the first step in the cycle is you choose detections from our portal. So we have a portal which where we expose all the detections which we have, and you can choose whatever detections you want from that portal. We can give you recommendations if you're interested, but ultimately it's up to you to choose whatever you want. So there's no restriction on what you can choose. We validate if the detections are feasible in your environment. I mean, sometimes some things are just not feasible in a specific environment. On average, I would say around 5% of the detections which we have are not feasible in some of the environments. So that might be because there are too many false positives. That might be because some data sources are missing, might be because there is a different audit policy which is configured in your environment. So around 5% of those detections will not work. And that's what we validate up front. Once that's validated, we tune the detections to your environment and we stage it, including the documentation for deployment. We don't directly push it in there because we want to avoid any type of accidents or flooding your SOC or whatever. So we always first stage it and have a moment together with you to talk about it. That's the next step. So we discuss the tuning together. We think that this specific application, which is generating these log lines, we think that's a false positive. Do you agree? Yes or no? Basically, that type of discussion. And then finally, when everything is said and done, we just push the detections from staging to production. And basically, you're free to push it yourself, or we can push it for you, whatever you prefer. I guess also important to note that those detections are all running inside your own Sentinel or inside your own Defender instance. We just provide you the documentation, we provide you the logic and the means to deploy it, but you get to see and you get to run the full logic of those detections. It's not running in our environment, and we don't get to see your data. That's very important to recognize. We have roughly 3 models. So we have a model called Booster. One is Pro and Enterprise. So the first one, the Booster one, is if you want to have a one-time set of detections. So you can get 5, 10, 15, 20, whatever number you want. You get the detections. We implement them for you one time. We tune them for you one time. And that's it. It's basically like a very scoped project, so to speak. You can have the second version, which is Pro, which gives you regularly new detections, so X number of detections per month or per quarter, whatever you prefer. And then we do the same service, but on top of that, we also provide you with detection as code pipelines, and we do the maintenance for you of those detections. So if there's a new version, we deploy it for you, but also tuning, ongoing tuning is also part of that service. And the third one is Enterprise, where you basically get access to everything which we have. So you get access to the full repository of detections. There is, of course, a limitation to how much we can tune in your environment. But on top of that, you're basically allowed to access any detection you want, deploy them yourself, and tune them yourself if that's something you want. And that's the enterprise version. Going back to the slides. Thanks, Olaf.
Yeah, and of course, detections are one thing. We've learned by testing a lot in customer environments and working together with a lot of our customers, is there's way more necessary. So one of the things that we sometimes see lacking in environments is where the data itself is not really monitored. So are still my logs flowing in the way I expect? So we're currently working on a solution to support with that. The next two items we're working on are quite well advanced, and we're already in a POC stage and proving to be extremely successful. So we've built our own risk-based scoring algorithm where we can correlate all the alerts from all the platforms and services that you might have to provide a sort of cadence of alerts in a sequence of alerts instead of single alert incidents. And at some clients, we already seen some huge reduction in false positives and catch some true positives that would have been missed otherwise. We're working on some deception and detection combinations, so honeypot solutions or some configuration towards that. A lot of guidelines around how to configure your logging, improve it, so that you actually get the most value out of your SIEM solution. And one of the last ones that we're also close to releasing is an automation and enrichment framework where we can contextualize on your assets, on your resources, on your attack paths, and add some context for the analyst or even some automated responses to improve there. So that's probably also the roadmap for our next webinars, where we'll talk a little bit more about our risk case scoring framework, the automation that we can provide together with enrichment and all the correlation, which is closer to what traditionally is called a SOAR. So with that, we still have 7 minutes left for some great questions that we saw pop up in the chat already. Do you want to take the first one, Henry?
Yeah, sure. So the first question is asking, my company is paying for an MDR service based on Defender EDR, where the service includes some custom detections. The MDR provider has many customers, so we feel that not even custom rules are specific enough. They have to work for all the customers in their environment. Would your custom rules provide additional value here? So I think that this question is fairly straightforward because the way it works for us, at least, is that the detection which we provide are, let's say, tuned to your specific environment and to your data. So I think, yes, our rules provide additional value here because the attack technique is the same, let's say, across the world, across the board. But we make the detections which are meant to detect specific attacks specific to your environment by tuning them to your environment. And that's specific for each environment. So it's not tuned on MDR level, but it's really tuned on individual tenant or individual organizational level. I hope that kind of answers your question. I think it was from Marcus.
Yeah, and I think one final benefit to add there is, as we made the conscious choice to not provide an MDR service, so we have our full dedicated time for R&D and quality improvements, where an MDR usually has to juggle the same as you would internally with, hey, there is a new incident, so I have to look at that now instead of finishing my detection. So we have dedicated focus time, which would improve the quality significantly, in our opinion. Other question is the lab environment, is it on-prem or is it based on some automated deployment in the cloud, or can it even be modified on the fly and scrapped quickly if not used? So we started with an Azure-based lab. Turns out that we use it not 24/7, but 5 to 6 days a week by multiple people. Turned out to be fairly costly for a small company like ourselves. So we have a mix between a couple of dedicated servers with some automation around it and some cloud resources where we actually need the cloud because we use Azure resources and these kinds of things. So it's mixed. It's 95% automated. Only some of the patches we need to do manually because we like to stay in control and have some control over what we do and do not update.
So the next question, I'm not completely sure. So the question says, by behavior patterns, would that include or cover UABA from Sentinel? So I'm going to interpret it as is UABA being used as a data source for building detections? I think the answer to that is partially. So we use UABA mostly to, let's say, as providing context to other detections. So let's say we have a specific detection looking for a specific attack behavior. And then we utilize UABA data to fine-tune the detection to make it even more high fidelity. So it's not directly used as source, but it's more used as input for, let's say, decision making and removing potential false positives. I hope that kind of answers your question.
And I think another question is whether we use a custom pipeline that incorporates the tuning for the client environment, or if we push a general rule to the environment, and if we have access via Lighthouse or something else to finalize the tuning. So in most cases, we do have access via a Lighthouse construction, or we get a guest account in a customer's environment, or we work with an app registration. It depends a little bit on the company's policies. We prefer, of course, a Lighthouse solution because we kind of have the access right away. We do have custom pipelines for every environment that we deploy, even if you have 2 different environments, and we tune per client. So we basically how we design our rules is we basically design one general rule and we tune it per environment, which will be automatically generated for that environment. So we have placeholders and templates that we incorporate into our base rules so that we can dynamically generate it for every new environment. So if we change our base rule, we can generate a new rule for every environment that we have onboarded. Hopefully that's clear.
And take the question on the financial side. So I think there was someone asking, can you share a rough cost model for the service? I think the answer is it really depends on, let's say, what you want and what you're looking for, but I can share at least a rough estimate. So if you're going for the booster option, which is like a one-off set of detections, again, it depends on a lot of factors, but I think it starts from around 20K for a one-time implementation of those detections. And if you go to the Pro model, it's around 60K a year. And for the enterprise version, where you get access to basically all the detections and everything which we have, is around 125K a year. Those are like the rough estimates for the starting prices of those services. But again, it really depends. If you're interested in more details, please talk to us so we can provide you more exact quote depending on your requirements and what you're looking for.
Yeah, and these prices are in euros for the people that are from different regions. So in your currency, it might be different, but we'll figure out a way to work together. I think the final question I'll try to answer quickly because I'm also conscious of your time and I want to be respectful of the hour, is a person that works for an MSSP with multiple Sentinel clients and a wide range of different tech stacks. How would you go about detection engineering in this case for completely bespoke detections and complete knowledge of each client environment? Well, yeah, that's sort of where we can dedicate our time to do this. And I have to be honest that we primarily focus on detections that will work for multiple environments. So if you have a specific log source for a custom application that will be out of scope for our solution. We can still help you out, but that's from an additional fee. But trying to understand the environment is part of our service, right? So that's basically where we can distinguish ourselves between a more common just here is a detection and good luck with it solution, and where we can actually fine tune it for that environment. We need to talk to the clients. We need to understand their implementation, because otherwise there's no value. So we had to answer that shortly. If you're interested in more details, we can always have a chat later. But with this, I kind of want to wrap up. Thank everybody for their attention. Great questions. Our details are at the slide that's still showing. So if you're still curious about more, feel free to reach out via one of the means on the screen. Or if you have another way and you think that works, that's also fine. We're happy to share more if necessary. And I hope you have a great day, rest of your day.